Welcome to our countdown of the 10 best scientists of the last 100 years. These brilliant minds have made groundbreaking contributions to science and technology, shaping the world as we know it today. From the vastness of space to the intricacies of the atom, these individuals dared to push the boundaries of human knowledge, unlocking mysteries and igniting our collective imagination. Their discoveries have revolutionized our understanding of the universe and our place within it, paving the way for countless technological advancements and inspiring generations of future scientists. Albert Einstein, a name synonymous with genius. He wasn't a fan of formal schooling, but when you look up the word autodidact in the dictionary, you might find his picture there. He revolutionized our understanding of gravity. Imagine space and time not as separate entities, but as a single fabric, warped and curved by the presence of matter and energy. That's the essence of Einstein's general theory of relativity. It's like placing a bowling ball on a trampoline. The ball creates a dip, and any object rolling nearby will be drawn towards it. That's gravity, the curvature of space-time caused by massive objects. His theory also predicted the existence of gravitational waves, ripples in space-time that travel at the speed of light. It took a century. But in 2015, we finally detected these waves, confirming Einstein's brilliance yet again. And don't forget E equals mc squared, his most famous equation, demonstrating the equivalence of mass and energy, a concept that underpins our understanding of nuclear energy and the very heart of stars. Marie Curie's story is one of dedication, perseverance, and a touch of tragedy. Born Maria Sklodowska in Poland, she moved to Paris to pursue her passion for science, a field largely dominated by men at the time. This was a time when women in science were as rare as hen's teeth. But Curie wasn't deterred. She worked tirelessly, often in primitive laboratory conditions, alongside her husband, Pierre. Together they delved into the invisible world of radioactivity, a term she coined herself. Their research led to the discovery of two new elements, polonium and radium, forever etching their names in the annals of science. Curie's work wasn't just about abstract theories, it had real-world applications. During World War I, she helped equip ambulances with X-ray machines, saving countless lives on the battlefield. She was the first woman to win a Nobel Prize, the first person and only woman to win Nobel Prizes in two different scientific fields, and the only person to win Nobel Prizes in multiple scientific categories. Richard Feynman was more than just a brilliant physicist. He was a showman, a teacher, a bongo player, a safecracker. He brought a sense of joy and playfulness to the often intimidating world of quantum mechanics. Feynman's work on quantum electrodynamics, or QED, helped us understand the interaction between light and matter. He developed a way to visualize these interactions using diagrams, now known as Feynman diagrams, making the complex world of subatomic particles more accessible to generations of physicists. But his true passion was teaching. He had a knack for explaining complex ideas in simple, intuitive ways, using humor and everyday examples. His lectures at Caltech were legendary, often packed with students eager to witness his infectious enthusiasm for science. Chapter 4, Rosalind Franklin, Unraveling DNA's Secrets. The story of DNA's discovery is incomplete without acknowledging the crucial role of Rosalind Franklin. Using X-ray diffraction, Franklin captured photograph 51, an image that would change biology forever. This picture revealed the double helix structure of DNA, the very blueprint of life. Imagine a twisted ladder, with each rung representing the base pairs that hold the genetic code. That image, captured by Franklin's meticulous work, was the key. Unfortunately, Franklin's contributions were not fully recognized during her lifetime. Her work was shared without her knowledge, and she was largely left out of the Nobel Prize awarded for the discovery of DNA's structure. Her story is a stark reminder of the importance of recognizing the work of all scientists, regardless of gender or any other factor. Chapter 5, Stephen Hawking, Exploring the Universe from a Wheelchair. Stephen Hawking was a man who defied the odds. Diagnosed with ALS at a young age and given just a few years to live, he went on to become one of the most renowned physicists of our time. Hawking's work focused on the most enigmatic objects in the cosmos, black holes. He showed that black holes aren't entirely black. They emit a faint radiation, now known as Hawking radiation. a discovery that shook the foundations of physics. But Hawking wasn't content just publishing groundbreaking research in scientific journals. He wanted to share his passion for the universe with the world. His book, A Brief History of Time, became an international bestseller, bringing complex cosmological concepts to the masses. His unique perspective on life, the universe, and everything in between continues to inspire millions around the globe. Chapter 6. Niels Bohr, architect of the quantum atom. Niels Bohr, a Danish physicist, made significant contributions to our understanding of the atom and the development of quantum mechanics. He proposed a model of the atom that challenged the classical view, suggesting that electrons orbit the nucleus in specific energy levels. Imagine the atom not as a miniature solar system, but as a series of concentric shells, each representing a different energy level. Electrons could jump between these levels, but only by emitting or absorbing specific amounts of energy, leading to the emission of light at specific wavelengths. This model, though later refined, revolutionized atomic physics and explained the spectral lines observed in the light emitted by different elements. Bohr also played a pivotal role in the development of quantum mechanics, engaging in lively debates with Einstein and other prominent physicists of the time. His contributions laid the foundation for our understanding of the subatomic world and its bizarre, counterintuitive rules. Chapter 7. James Watson, Unlocking the Code of Life. James Watson, along with Francis Crick and Rosalind Franklin, unraveled the intricate structure of the DNA molecule, the blueprint of life. This discovery revolutionized biology, providing the foundation for understanding how genetic information is stored, replicated, and passed down through generations. Watson's later work focused on the Human Genome Project, an ambitious endeavor to map out the entire human genetic code. This project, completed in 2003, has had profound implications for medicine, allowing us to understand the genetic basis of diseases and develop new diagnostic and treatment strategies. Chapter 8. Linus Pauling was a scientific polymath making groundbreaking contributions to chemistry, molecular biology, and peace activism. He was awarded the Nobel Prize in Chemistry in 1954 for his work on the nature of the chemical bond, explaining how atoms link together to form molecules. This work laid the foundation for modern chemistry and our understanding of complex molecules like proteins and DNA. But Pauling's contributions extended beyond the lab. He was a vocal advocate for peace campaigning against nuclear weapons testing and promoting international disarmament. His efforts earned him the Nobel Peace Prize in 1962, making him the only person to receive 2 unshared Nobel Prizes. Linus Pauling's life and work exemplify the power of scientific inquiry and the importance of using knowledge for the betterment of humanity. Chapter 9. Barbara McClintock's journey in science was marked by independent thinking and groundbreaking discoveries. In the 1940s and 1950s, her research on maize chromosomes led her to a revolutionary finding. Genetic elements could move around on the chromosome, jumping from one location to another. This phenomenon, known as genetic transposition or jumping genes, challenged the prevailing dogma of a static genome and revolutionized our understanding of heredity. McClintock's work was initially met with skepticism from the scientific community, but her meticulous observations and rigorous analysis eventually won over her critics. In 1983, she was awarded the Nobel Prize in Physiology or Medicine, a testament to her perseverance and the profound impact of her discoveries on genetics and molecular biology. Chapter 10. Carl Sagan was more than just an astronomer. He was a science communicator extraordinaire. He possessed a unique ability to convey complex scientific concepts in a way that resonated with people from all walks of life. His landmark television series Cosmos brought the wonders of the universe into living rooms around the world, igniting a passion for science in a generation. Sagan's contributions to astronomy were equally significant. He studied the atmospheres of planets, the conditions for life beyond Earth, and the search for extraterrestrial intelligence. He reminded us that we are all made of star stuff, the remnants of ancient stars scattered across the cosmos. His legacy continues to inspire us to explore the universe with wonder and curiosity. Thanks for joining us on this journey through the incredible achievements of these 10 scientists. Their work continues to inspire and drive scientific discovery today. From the smallest atom to the largest galaxy, their insights have shaped our understanding of the universe and our place within it. Their stories are a testament to the power of human curiosity, the relentless pursuit of knowledge, and the importance of imagination in unlocking the secrets of the cosmos. Don't forget to like, share, and subscribe for more fascinating content.